Okay, so we're going to start with our exercise from last time, which was given the points 3, 1, 1 and the point Q, negative 1, negative 2, 0. We want to find the equation of the line that goes from P to Q. So remember, that's going to be R of t, which starts at P and goes in the direction of V, where V is the vector PQ, which is Q minus P as a vector quantity. So this is negative 1, negative 2, 0 minus 3, 1, 1, and that's negative 3, negative 4, negative 3, negative 1. So our equation of the line is 3, 1, 1 plus t times negative 4, negative 3, negative 1, which we can write, I guess, parametrically as the following, where x of t is 3 minus 4t, y of t is 1 minus 3t, and z of t is 1 minus t. And notice here, when t is 0, you get exactly the point P, which is 3, 1, 1. And when t is 1, you get the point negative 1, negative 2, and 0, which is Q. So indeed, this is the line going from P to Q in positive time, and it's parameterized by these equations. Okay, we're going to do now, we're going to talk a little bit about intersecting lines and skew lines. So pretty much, if you're given any two lines in R3, there's a couple of possibilities. So one is that they intersect in one place. So you could have, so here is our three-dimensional coordinate system. You could have some line going like this, and then another line going like that, where they intersect at one point. Skew lines mean they just don't intersect. So this is, we have either the lines intersect, assuming they're two different lines, either they intersect or they're what's called skew. Or they're skew, or they don't intersect. Okay, so let's do an example here where we want to find the intersection of two lines. So let's say line 1 is given by x of t is negative 1 plus t, y of t is 2 plus 3t, and z of t is 1 plus 5t. That's equations for L1. L2, and notice here I'm not going to write this as a function of t, and I'll explain why in a second. This is, let's call this x1, y1, z1. Let's call this x2 is just s. So that's the letter s. Y2 is 1 minus s, and z2 of s is negative s. Now, why do we use a different letter? Because what we're going to do is we're going to set these equations equal to each other. If they're going to intersect, well, we need to check when the x values are the same, when the y values are the same, and when the z values are the same. Okay, now the reason why we don't, so let me write this in a different color, we don't write L2 as a function of t, because that would say if this had to be t's here, if this was t and this was 1 minus t and this was t, that would mean that not only do these have to intersect, but they have to intersect at the same time, because that would imply that intersection occurs simultaneously in time. Simultaneously at a single t value. Think of these as we have sort of particles that are floating across space, and if the particles had actually hit each other, well, then you would plug in t. But we don't, since we're just thinking of intersection of lines overall, not in terms of what time it occurred. We have to put a different variable, and we choose s. Okay, so that's an important side little fact here. So let's go ahead and find that intersection. So let's solve the equation 1 for, well, we've pretty much solved it for s. Let's just plug that into the next one. So 2 plus 3t is equal to 1 minus, and from equation 1, we get negative 1 plus t. So you have 2 plus 3t is equal to 2 minus t. The 2's cancel, and we get 4t is equal to 0, so hence t is 0. Well, if t is 0, then from equation 1, sorry, let's see, from equation 1, what do we get? Equation 1, let's label this as equation 1, equation 2, equation 3. So from equation 1, we get s equals minus 1. So let's check if these work out. Maybe they do, maybe they don't, because there's 3 equations we still have to check. So at t equals 0, we have x1 is equal to negative 1, y1 is equal to 2, and z1 is equal to 1. Right? So I think over here now, so let's set s to be 0. If s was 0, by the way, sorry, this last equation was negative s. Forgot to put the negative sign here. In equation 3, that should be a negative s inside. So at s equals 0, what do we get? Well, at s equals 0, we get, sorry, s was not 0, s was minus 1. S was minus 1 here. So at s equals minus 1, we get x2 equals minus 1, y2 is equal to 2, and z2 is equal to 1. So indeed, these are the same. Note that these, so at time 0, we have the point negative 1, 2, 1. At s equals negative 1, we have the same value. So these are the same, and hence they intersect. So the point of intersection, so hence the point of intersection is the point that we got here, which was negative 1, 2, and 1. So it is p equals negative 1, 2, and 1. Okay, so let's give you guys a little exercise here to show that another set of 2 lines are actually skew. So show L1, L2 don't intersect. And if they don't intersect, they're called skew lines. So L1 is the following. X equals 1 plus t. Y1 equals negative 2 plus 3t. Z1 is equal to 4 minus t. So this is the parametric equations for line 1. For line 2, we have x2 being 2s, y2 being 3 plus s, and z2 being negative 3 plus 4s. Okay, so we will do this exercise, and then we're going to move to planes in the next